In this screencast, I'm going to present a proof to the theorem that every natural number greater than 1 has a prime factorisation. That is, every natural number can be written as a product of factors which are all prime. We're going to prove this by induction. So to start with, we consider it in a base case, in this case 2, which is the smallest prime number, and we see that the statement is true in this case, which is clear. 2 is a prime number, and so its prime factorisation is just itself. The next step of our proof is to make an assumption. We assume that the statement we are trying to prove is true for all natural numbers up to m. That is, every number from 1, 2, 3, all the way up to n-2, n-1, n, can be written as a product of prime factors. Our next step is to consider the number n plus 1. If n plus 1 is prime, then it is its own prime factorisation, and so we are done. But if it's not prime, that means there exists q and r, which are natural numbers, and which are greater than 1, but smaller than n plus 1, which are factors of n plus 1. So n plus 1 equals q times r. Now q and r are both strictly less than n plus 1, therefore they are less than or equal to n. We assumed earlier that all numbers which are less than or equal to n, but greater than 1, have a prime factorisation, and so we assume that q and r have a prime factorisation. From this, it is clear that n plus 1 must also have a prime factorisation that is simply the product of the prime factorisations of q and of r. Now, hopefully, you can see that we have in fact proved the theorem. We have shown that a number has a prime factorisation if all of the preceding natural numbers have a prime factorisation. It is clear to see that with this argument we have shown that every number has a prime factorisation,